Hello everyone! In this virtual lab, we're going to investigate the stress-strain graphs for steel. You have seen how a load extension graph can represent the behavior of a specimen as it is stretched. To see how a material behaves as it's stretched, you need to look at a stress-strain graph. Let's select the short, thin steel specimen from the specimen tray, and let's select the graph as well as stress-strain. We're going to stretch the material until it breaks. What shape is the stress-strain graph? Exactly, it's a straight line passing through the origin. And what is the mathematical relationship between stress and strain? Yes, stress is proportional to the strain, and the strain is proportional to the stress. Now we're going to select all three steel specimens and stretch them. Explain why you see a single graph for the three specimens. Well, all three specimens have the same stress-strain graph because no matter what size and shape of the specimen you have chosen, a particular value of stress produces the same value of strain. So if we remove the curve of sample 3, we will find the curve of sample 1, which is pink, and the curve of sample 2, which is green. And if we remove sample 2, the curve for sample 1 is obvious, as you can see. Let's select the curve of sample 3. As you can see, it overlaps the curve of sample 1. So the stress-strain graph for the same material is the same no matter what is the size and shape of the specimen.